say something weird.
I said, let's get fired up.
Oh.
Yeah, I figured you'd be used to it because you listen. If you do watch a video, you always listen at 1.5 or 2 times speed. And so I just have to talk real fast to make it sound normal. All right. Today is Monday, March the 8th. We're here at Spain Park High School, advanced level chemistry. Woo! You get a day off tomorrow. All right. So I'm probably just going to give you a hard copy of the e-learning assignment, which is going to be more practicing writing and balancing equations, and just kind of going from there. So let's talk about the problems that we did on our first e-learning day. So I do believe, what did we have to do? We did 1 through 5, and then 11 through 26. Okay, notice there's 2 21s. I don't know if anybody noticed that. This is obviously a typo in the textbook. Okay, so if I'm just going to write zinc, what's zinc going to be? Zn. What state do you think it would be? Now, you didn't have to really put the states on this one, but what state would zinc be a metal? A solid. And you look on the periodic table and you see sulfurs. What color on the periodic table? What color is the symbol? What color is the symbol? Black, meaning it's a solid at room temperature as well. And you're going to have to do something in order to get that to react, probably heat them up or something. But what are we going to make?
ZNS.
Okay, Sam, ZNS. Why ZNS?
Because it's a composition reaction and it's combining.
I know, but why ZNS, not Z2S, ZS2?
Zinc only has one oxidation state.
Of
+2.
and sulfur's only oxidation state for the negative is -2. Okay, now that's something, again, real important. -3, -2, -1 are the only possible negative oxidation states for the nonmetals. They can have a bunch of positive oxidation states, but that's almost always when they combine with oxygen. So just the minus is the one we almost always use. Because when it's combined with oxygen, it's probably going to be in a polyatomic ion. We just care about the charge on the ion and not the individual charges. So, do we have to balance this?
No.
Well, that's pretty easy. Okay? Potassium chloride. What's potassium, Clay, what's potassium chloride's formula going to be?
KCl.
KCl. Okay? Now, is it just, again, I want to make sure we're always balancing charge, +1, -1. Plus silver nitrate. Let's keep going, Clay. You're on a roll.
AgNO3.
AgNO3. So what type of reaction is this? Is a composition. What's this one going to be? Double replacement, right? Okay, so what are we going to make?
AgCl and then the potassium nitrate.
And potassium nitrate. And everything's +1, -1. Now, in a reaction like this, we're going to have to either form a solid, liquid, or a gas. And remember, we've learned the big 3 solubility rules. All alkaline metals are soluble.
Anything with nitrate.
Nitrates and ammonium. So between these two, which one would be soluble? The KNO3 has got an alkali metal and a nitrate. So this would have to be my precipitate if the reaction is going to occur. Now you didn't have to put any of that on there, but you are going to have to know how to do all that. So I'm just kind of highlighting. Okay? Because they're not telling you this is aqueous, but almost always these have to be aqueous. And we started at the very end of class, and we definitely have to go over more of it, writing the total and net ionic equations for these things. Okay? Because when you we can even just do that right now. When you put this into water, how does it dissolve? Remember we watched that video?
The H circles around each
ion.
Each ion, and it causes the ions to break apart, right? So it doesn't dissolve as a KCl. It dissolves as a K plus surrounded by water and a Cl minus surrounded by water, right? So for my total ionic equation here, okay, which you are not required to do, I'm just kind of teaching and going over at the same time. This is going to dissociate, break apart into K plus aqueous and Cl minus aqueous. In other words, when they're in water, they're not going to be together anymore. We saw again that little video of the salt dissolving in water, the water surrounding it. That's what happens with every ionic compound when it dissolves in water. I know this is deep, but ionic compounds are composed of ions. Okay? So when they dissolve as ions, not as molecules. So what's silver nitrate going to break up into? Ag plus and NO3 minus. You see, if we put if I take two ionic compounds and I wanted them to kind of mix together, okay, this is one ionic, this is another ionic. When they're held rigidly in place as a solid, they can't interact, they can't move, and we can't, swap partners, so to speak. But when you put them into water, the water then breaks them apart and gives them that ability to rearrange. So now, see, silver and chlorine, they have a thing for one another, but when they're locked into these other relationships as a solid, they can't get together. Once you put them into water, now the two of these can get together, and we're going to make AgCl solid, and their bond is too strong for the water to break apart. That's my precipitate. But potassium and nitrate, they just kind of still doing their own thing. Does anybody remember what we call those ions that don't change?
Spectator ions.
Spectator ions, good. So if we cross out our spectators, the real reaction that's taking place, the net ionic, is going to be what? What's left?
Cl minus plus Ag plus is AgCl.
Okay, so that's the really all that's happening is the Ag plus from the silver nitrate is combining with the Cl minus. The potassium nitrates they're there floating around in the solution, but they're not doing anything. Okay? That's the whole reaction. All right, so the net ionic gives us the real deal. What's going on? I feel like I'm missing out on something.
It's just been a long day, Mr. Hart.
Already? A long day, a long Monday? All right, so that was number 2. Number 3, calcium oxide in water. What's calcium oxide going to be? CaO. Okay, plus water, and I'm going to write water as an HOH. That's going to be a solid. And it tells us that it's going to make calcium hydroxide. Okay, but what's the formula going to be for calcium hydroxide?
Parentheses and put silver oxide.
Okay, why?
Because OH is -1, Ca is.
So this is a 2 plus and this is a -1. A lot of y'all want to try and do that. But what does that tell me? It's water backwards, but I only have 2 hydrogens. I don't have 2 OHs. I need 2 hydroxides. The -1 charge is on the whole thing. So you have to have the parenthesis and the 2. And it's balanced. What type of reaction is this? Composition. Now remember we talked about this is the base without water. You put it into water and it makes the base, the hydroxide. Okay? We call this a basic anhydride.
So the calcium is that hydroxide?
Calcium hydroxide is the base. This is the base without water. But the anhydrides act just like bases, and so because once you put them into your stomach or whatever, then it's going to make the hydroxide. All right, so number 4, sodium hydroxide and hydrochloric acid. Sodium hydroxide, hydrochloric acid means it came from the chloride. What's that going to make? Is NaCl going to be soluble or a precipitate? Why?
Alkali metal compound.
Alkali metal, sodium. Plus we know salt dissolves, that's why, you know, when you swim in the Gulf, it's salty. Okay? Plus you put salt in when you're making your spaghetti noodles and your pasta. Or if you have contacts, you have a saline solution that you have to, you know, put the contacts into. Plus water, what's the state of water though? Liquid. Now, this is what type of reaction? Double replacement, right? So, let's just do a total and net again for this one. What's this going to dissociate into? Na plus and OH minus. Okay, notice I'm putting the charges because they're, quote, ionic equations by definition. An ion is a charged particle. It's not breaking up into sodium Na because that would blow up with the water. Okay, Na plus and OH minus. The acid breaks up into H plus and Cl minus. Now is this going to be together or apart? Apart, because it's aqueous. The only solid, liquid, and gas are going to be together. Only aqueous break apart. And it's aqueous ionic. Not any aqueous, just aqueous ionic compounds. Na plus Cl minus. Does water break apart? No. What I just said. What's the only one that breaks apart? Aqueous. Solid, liquid, and gas always together. Water is very stable. It doesn't break apart. So what are my spectators? Na and Cl. So what's my net?
Peroxide.
No.
Oh, wait.
Hydroxide.
Yeah.
Plus the H plus makes H2O. Y'all, this is the net ionic equation for all acid-base neutralization reactions. All acids have H plus, all bases have OH minus. They come together, they neutralize each other because they make water.
If all of them are spectators, then what do you do?
If they're all spectators, then there's no reaction. That's why we have to have a solid, liquid, or a gas form. That's a great question. If they're all aqueous, nothing happens. They're all just floating around, the ions, they're all just floating around, no one's doing anything. It's like a junior high dance. Okay? Everybody's just kind of there. Okay, and then number 5. Magnesium bromide plus 2 and minus 1 plus chlorine. But what, Cl2, because it's one of our 7 diatomic elements. You just have to know those 7. Gens and enes. Chlorine, fluorine, bromine, iodine. I know it's iodine, but make it fit the trend. Oxygen, nitrogen, hydrogen. Those 7. Starts at a 7, makes a 7. Always just, but only when it's by itself. Notice water, it's only 1 oxygen. When it combines with things, it can combine KClO3. We can have any number of oxygens. It's just when it's oxygen gas, it's going to be O2. Chlorine gas, it's Cl2. And what's this going to make?
MgCl2 plus 2.
So we're just swapping the negative ones here. MgCl2 plus Br2. So what kind of reaction is this? Single replacement. Are we all good with that? Does anybody have any questions about that part? So if we just take the word, now obviously, given the words, we have to, this is why we had to do the previous chapter, writing formulas from names and naming from formulas. So we had to do that first, because really this is just nothing more than putting that together. Okay? All right, so now that we got to predict the products. Wax on, wax off. You guys do know what I'm talking about when I say wax on, wax off.
Yes.
You have seen that Karate Kid with Mr. Miyagi, right?
Yes.
All right. I mean, you guys, do you guys watch the new one where they're old?
Cobra Kai, yes.
Is that Cobra Kai? Yeah, I guess it is Cobra Kai.
That was just fine.
Yeah, that's pretty stupid. Okay, so number 11. Now they tell you that it's a composition reaction, so sodium plus iodine, what's iodine gonna be? I2.
I knew I screwed one up.
Okay, so what's that gonna make? Does it make NaI2? Okay, wait, it's just gonna make, because you balance charge first. Balance charge, so sodium's +1, iodine's a halogen, so it's gonna be -1. So it's just NaI. Okay? Now I have to balance atoms with coefficients. So I put a 2 there and a 2 there. Okay? So balance charge first. The subscripts don't automatically carry over. Calcium plus oxygen. Again, it's going to be calcium's +2, oxygen's -2, so it's just going to be CaO. But now we balance it by putting a 2 and a 2. Balance charge first with subscripts. Balance atoms last with coefficients. 13. Hydrogen plus chlorine. Hydrogen is +1, chlorine is -1, so it's just HCl. But we put a 2 out in front to balance it. Decomp. Now, nickel 2 chloride. Now, you have to realize you will have the rules. And if you go in, it says metallic chlorates decompose into the metallic chloride and oxygen gas. So what's the metallic chloride going to be? Metallic chlorates decompose into the metallic chloride plus oxygen.
So NiCl2.
Ni, and it tells me it's nickel 2, so it's going to be NiCl2 plus O2, oxygen gas. Now we have to balance it. 1 nickel, 2 chlorines, 2 chlorines. How many oxygens do I have? 6. So I have to put a 3. Yes, sir.
On that, do we have to put the solid?
No, I mean,
Solid gas.
That's what it would be, but you don't have to put it. If you have a description, like I said, solid nickel 2 chloride is heated to produce solid nickel 2 chloride and oxygen gas. So it kind of tells you. Now in the lab, that's going to be due on Thursday, you observed the states. You saw what they were. So you can include them based upon what you saw, and you should have observations that kind of back that up. You know, you saw bubbles, you know, any of the solutions, anything that you used was aqueous. There weren't any liquids. So anything that was, quote, liquidy was really a mixture, a solution. So those are all aqueous. But you put the iron filings into the copper sulfate, so the iron filings are what state? solid into the aqueous copper sulfate. And then they kind of swapped, and so you should, you know, the reddish brown forming on the bottom. So we know that that's a solid. Okay, so you just from your observations on that one, you need to have states. Okay, so 15. But just when I give you something like this, you're not gonna have to do it. And states is one of the lower priority things as well. It's one that gives students a big headache, but it's low priority. Barium carbonate. Barium's +2, carbonate is CO3, 2-, actually we'll say 2+. So metallic carbonates, what do they decompose into? What common compound looks like CO3?
Carbon monoxide.
CO2. So if we take a carbon dioxide out, we're left with a barium oxide. Do we have to balance that? Next one, zinc hydroxide.
Does it matter which order we put it in?
No. Zinc hydroxide, and all of these are when heated. What common compound OH gets made? Water. So take a water out. There's 2 H's and 2 O's. We took out 2 H's and 1 O. That leaves zinc oxide. Metallic hydroxides decompose into the metallic oxide and water. Now again, you're going to be given those rules. You don't have to memorize those. You just to be able to recognize this is a metallic hydroxide, this is a metallic carbonate, this is a metallic chloride. Are we all good with that? All right, moving on. 17, single replacement. Aluminum plus sulfuric acid. Now these are the ones that are going to give you a problem. What's sulfuric acid?
H2SO4.
H2SO4. Okay, make sure we remember how to name everything. So, what are we going to make?
Aluminum sulfate hydrogen.
Okay, aluminum sulfate, but what's the charge on aluminum? 3+. What's the charge on sulfate? 2-, so what do we do here?
Crossing.
Crisscross. You don't have to jump. You guys don't know who crisscross is.
I know,
You do?
but the kids, they wore their clothes back.
Yeah, the kids wore their clothes backwards and they said, jump for your love. Jump. See, crisscross, but you don't have to jump. I'll have to play it for you. They're like 10 years old.
And they're dead now.
Are they?
One girl
Okay.
took one down for drug overdose.
That's what happens when you get too much money too young. Okay, aluminum sulfate plus what's my other product?
I promise if I had a lot of money, I'm not gonna order those.
When you get just into that lifestyle. Hydrogen gas, so now we have to balance this bad boy.
2
Okay.
the aluminum.
3.
And put 3 in
Put a
the
2, I need 3 sulfates,
Yeah.
and then put a 3 for the hydrogens.
Oh, aluminum. Dang, I was close.
Dang, I was close. Potassium iodide, Ki, plus chlorine. Chlorine is Cl2.
They're dead now.
I didn't know they were dead. Cause they tried to make a little I think what happened is they tried to do a comeback as 30-year-olds, and they weren't quite as cute, you know, and so it didn't happen. So what's this gonna make?
That's just crazy.
Potassium, but it's gonna be K is plus and Cl is minus, so just KCl. We don't bring the 2. And what's the other product? Iodine, which is now iodine by itself, so it is I2. So we have to balance it with a 2 and a 2. Stop me if you have a question. I'm trying to go fast. 19. Iron plus copper 2 nitrate. Copper 2 means it's 2+. Nitrate is NO3-, so what's the formula? No, over here, what's copper 2 nitrate, what's it gonna be?
I'll put a 2 on the parentheses.
We have to have a parenthesis and a 2. Okay, now, this would be aqueous because it's a nitrate. 2 solids aren't gonna react. So now we end up getting, now you get, it doesn't say, oh, it does say iron 3. Okay, so iron 3 nitrate. Hey, if it didn't say, you just go up and you get a pick, 2, 3, or 6. 3 is the bolded one, meaning the more common one. But if you pick 2, that would have been fine. But it tells you on this one, iron 3. So what's my formula for iron 3 nitrate? In parentheses, right?
Yeah.
Plus what?
Copper.
Copper. Okay, now this is very similar to the reaction we did. Instead of using copper nitrate, we used copper sulfate. The iron replaced the copper, and we saw that reddish orange, brown solid forming on the bottom. Now, I probably told y'all to choose, since sulfate's -2, you probably pick the iron 2, makes the balancing a lot easier. But iron 3 is the more common. All right, number 20. Now we're going to double replacement. Silver nitrate plus zinc chloride, and almost always in a double replacement, the reactants are aqueous. Just because that's, again, the only way they can rearrange. So what do we make?
Zinc, nitrate.
Okay, zinc nitrate, but
Yeah.
again, zinc is what charge? 2 plus, nitrate is, so the formula is going to be NO3 2 plus Ag, which is plus, and Cl minus, which is minus. Okay? Don't carry the subscripts, balance charge first. Now, you don't have to memorize all these charges. Zinc, you're going to have this periodic table. It's got the little 2 above it. So that tells me zinc's +2, silver's +1. You'll have this ion sheet, so you'll know nitrate's -1, sulfate's -2. You'll have all the ions. Okay? So you don't have to memorize anything, you just have to know how to apply. So what do I have to do to balance this?
Put a 2 on and then put a 2 on the AgCl.
Put a 2 on the AgCl. Now, which one of these would be my soluble one? Which one would be my precipitate? Because in order for there to be a reaction, one's got to be a precipitate.
Zinc's the
Over here.
the AgCl is the precipitate.
Okay, this is my solid because this is a nitrate. All nitrates are aqueous. Okay? These would both be aqueous just because that's the only way they can react with one another. 21. Copper 2 hydroxide. Cu is 2 plus, OH is minus. So what's the formula? CuOH2, like that. Do what? We have to have a parenthesis, that's right, because I need 2 OHs. Plus, where am I? 21, plus acetic acid. C2H3O2. So if this is acetic acid, what's the name of that ion?
Acetate.
That's the acetate ion, because A goes to ic when you make the acid. So acetate ion makes acetic acid. So what am I going to make? Copper 2 acetate.
And then water.
And acetate is C2H3O2. Now, if I can't remember the charge, hydrogen's +1, so acetate has to be -1. So it's -1. So what's the formula of copper 2 acetate?
Parentheses, copper parentheses,
2
plus 1.
plus water. And I'm going to write it as an HOH. Because the H plus is going to combine with the OH minus. Now I need to balance this.
Put a 2.
2 there.
And then on the one.
And a 2 there. We all good? So water's my stable compound in this. Is the double replacement reaction again. Water, here I'm forming a precipitate, a solid. Here I'm forming a liquid. And then finally, the other 21, iron 2 sulfate, SO4, 2 minus, plus ammonium sulfide. Ammonium is NH4 plus. Sulfide is just going to be the S2 minus. So what's that going to make?
NH4 parentheses 2S.
NH4, I need the 2. So now we're just going to swap and make iron sulfide, FeS, plus,
NH4 SO.
and again it's going to be a 2, SO4. Which one would be my solid?
FeS.
The FeS. Because all ammonium compounds are soluble. See those big three, if you just know those big three solubility rules, you can figure out almost all of them. Okay? Because you gotta have an alkali metal, you gotta have a nitrate to get most of these metals into solution. All right, 23. Well, no, so this was 21, this was the other 21.
For the
21B.
Yeah. 21B with their B spec.
All right.
Ion.
But then they went to 23. Say that again?
For 21B with their B spectator ion.
Yes. Which ones would they be?
Would
Assuming this is aqueous.
Would it be sulfate and ammonium?
It's always going to be the two things that are aqueous over here. Ammonium and sulfate.
So then it'd just be iron plus sulfur.
It's going to be,
Leads to iron sulfide.
it's going to be Fe2 plus, right, it'd be Fe2 plus S2 minus, making FeS.
So there can be more than one spectator ion.
There's almost always two.
Gotcha.
One positive, one negative. 23 says barium chloride and sodium sulfate. Barium chloride, sodium sulfate. Is everybody good as far as I've been going charges, making sure we know charges? Plus 2, minus 1, plus 1, minus 2. So what am I gonna make? Barium sulfate and
Sodium chloride.
sodium chloride, but it's Na is plus and Cl is minus, so I don't carry the subscripts, but I do need to put a 2 on the front, balance atoms and coefficient. Now which one would be my solid?
The BaSO4.
The BaSO4, barium sulfate. Solid, aqueous. 24, calcium plus hydrochloric acid. What's it gonna make?
Calcium chloride and hydrogen.
Calcium chloride, which is plus 2 and minus 1, so it's gonna be CaCl2 plus hydrogen gas, and we know hydrogen's one of the two. And this one, you look up on the solubility chart and say, oh, chloride, well, only silver, lead, mercury are precipitates, so this one would be soluble. You're not gonna just be expected to know that this is soluble, you have some kind of reference. But again, if you look up there, Cl minus, most chlorides are soluble, only silver, lead, mercury, and thallium form a precipitate, and calcium is not one of those 4. So it's soluble. And then and what type of reaction is this? Single replacement of a hydrogen in an acid by an active metal.
Mr. Hobbs, when you put a 2 in front of the HCl?
Yes, you would. Glad you caught that. Last one. Iron 2 sulfide plus hydrochloric acid. Iron 2 sulfide, that's really a solid, you wouldn't have to know that, plus hydrochloric acid is going to make H2S, and that's a gas, plus FeCl, Cl2. And that would be aqueous. Put a 2 right there. Now, smells like rotten eggs. That's the H2S gives you the classic nasty sulfur smell. It's also very, very toxic. You know, small amounts will kill you. Sulfur is a major impurity in all of our fossil fuels. So when and Exxon had a big refinery in Baton Rouge. And so I used to be able to take students there, we go on tours and whatever, but they would always say, you know, that, okay, this is where we're removing the sulfur, you know, but part of the byproduct is H2S, but they have sensors all over the place that if they sense the H2S gas being given off, they say, grab a gas mask and run, you know, because it's bad.
I see it. It's doing the low battery thing.
We got through most of it. Did it just do it?
I mean, the video's still running.
Try to charge it up.
Yeah, we're definitely only not.
Some.
No, it's pictures. The joys of video. We're still running? Does that mean it's still recording even though it's giving me a low battery?